Hey guys, welcome to today's lesson on reflections. So in our last section we were doing translations, which were a slide. For today we're going to focus on reflections, which is a flip. It's a transformation in which the figure is reflected in a line called a line of reflection. The reflection creates a mirror image of the original. So you're going to hear me talk a lot about mirrors, kind of in real life, what would that look like and how do those work. So essentially you want to think of your line of reflection as your mirror, and then your original would be you, and then the image would be your reflection. So one of the big things about reflections is that if you've ever noticed when you're looking at a mirror and you raise your right hand, it looks like it's your left hand in the mirror because it's that reflection piece to it. The same happens when we're reflecting figures. So I always like to point out that the point closest to the mirror is going to look closest in your reflection. So if you stand, I also compare this to when you stand really close to a mirror, you get a really close image of yourself. When you stand further away from the mirror, you start to see more of your height, more of your build, more of your clothing, because you have kind of more of your image in front of it. So the same is here. When we have an image, it is going to be flipped from the original. Whatever is closest to the mirror in the original is going to be closest in the mirror in the reflection, but it might just look like it's on an opposite side. So let's look at a couple examples and how you can reason through these. So tell whether the blue figure is a reflection of the red figure. So when we're looking at this red figure and we have our line of reflection marked, we want to look for a point closest to the mirror, and is that same point closest in the blue reflection? It is. You could do it the opposite way. Let's find the point farthest away. Is it still farthest away in the reflection? It's kind of that mirror image, the left is right sort of thing for it. Now when we look here in B, we can reason this one is not a reflection because the closest point to our line of reflection is actually now the farthest point from the line of reflection. That is not true if it was being flipped over that reflection line. So go ahead, you take a look at question number 1. Tell me, is question number 1 is the blue figure a reflection of the red figure? Now let's take a look at number 2. Is the blue figure a reflection of the red figure? Reasoning for both of these. Number 1, it is not a reflection, because if we look at this point of the red, we know that's going to correspond with this point of blue, and up here that point is farthest away from the line of reflection, whereas in the blue one it's the closest point to the reflection. That would not be a flipped or reflected image. In number 2, this is a kind of slanted line of reflection, but it still works the same way. This would be a reflection. We can see here on the red that these 2 points that are farthest apart are closest to the line of reflection, and then we see that here with the blue, those same 2 points are also closest to the line of reflection. So a couple key ideas that we want to kind of cover and we're going to talk about in our next written notes here is this key idea. Whoops, sorry, my camera started tipping there. All right, so in words, how would we say this? To reflect a figure in the x-axis, take the opposite of the y-coordinate. To reflect a figure in the y-axis, take the opposite of the x-coordinate. What you'll notice is these are almost opposites to each other. When we're reflecting in the y-axis, we take the opposite of the x. When we are reflecting in the x-axis, we take the opposite of the y. In algebra, we would show this that xy would go over the x-axis, would go to x. It looks like negative y, but I want you to think opposite y, x opposite y. And then reflecting in the y-axis, xy goes to the opposite of x, comma y. All right, let's go ahead and let's start on our paper notes. All right, you need this set of paper notes to continue on. The first thing we are going to do is we are going to cut on these 2 dotted lines right here, and then we'll fold those little doorways over. So go ahead and do that now. Cut just on the dotted lines, and then we'll fold the doors over so we have a foldable. Okay, so what I'm left with is I have these 4 little doorways that open up to our practice problems on the inside. So I'm going to do a little bit of color coordinating. You certainly can follow with that, or just do this all in pencil, up to you. So the first example that we're going to talk about is reflecting over our x-axis. So when we're reflecting over our x-axis, it is important that we think about where the x-axis is. And the x-axis is this line right here, which means we're going to make sure that when we reflect, we are crossing paths with that x-axis. So I always like to kind of use this example of like going to the x-axis. So looking at this original point that's here, I know that this point is, so if we count from my origin, so starting from the middle, count over, it's 1, 2, 3, 4 to the right, and 1, 2, 3 up. That means our ordered pair is at 4, 3. If I am just reflecting this point over the x-axis, I always like to think of that as, okay, let's take this point to the x-axis, and guess what? That's 1, 2, 3. That's 3 away. Now we're going to move it 3 away from the x-axis, and then that new point would end up right here. And my new point is at 1, 2, 3, 4, but instead of going up 3, now I need to go down 3. So my new ordered pair is at 4, -3. So see how by going just over the x-axis, this point doesn't move side to side at all. It's just moving down this way, which is why the change happened in our y-coordinate. So we would say for that at point AB, once you reflect it over the x-axis, that new point is going to be at A, your x would stay the same, and then your B would go to the opposite of what B was. Now, please notice that I'm trying to be very intentional in saying the opposite of B instead of saying -B, because if your original point, if your y is originally negative, okay, reflecting over the x-axis means it's going to be going to the positive. So if 4, -3 had been our original point, and then when we reflected it up, our reflected point's now 4, 3. So it's more about that coordinates being an opposite than it is being a negative. Okay. Now let's take a look at what happens when we reflect over the y-axis. So for these ones, we're going to make sure that that point reflects over the y-axis. So that little pathway, it should cross right over. So in this same problem, we are starting also at 4, 3. I would find that to move this point to the y. Now normally you don't have to draw these arrows. I'm drawing this for notes purpose to show which direction we're moving and how I like to count it out. So that arrow moving this point to the y-axis, we'd have to move it 4, which means we are going to move it 4 more after that y-axis. And now our new point is right here, which is at, since I start from my origin, since I'm going left to start, that means we're going to go -4 and then up 3. So this new ordered pair would be -4, 3. Noticing that we went from 4, 3 to -4, 3, we say that when reflecting over the y-axis, your x-coordinate, in this case A, is going to go to the opposite. So it becomes -A, not, oops, I said that wrong, the opposite of A to B. Kind of hard to catch yourself on saying that sometimes. But it's about the opposite of A, or the opposite of your x-coordinate, and then that y-coordinate stayed the same. Okay, let's go ahead and do some practice problems from these first, and then we'll work on the next two because they're done a little differently. Okay, so let's start here with our x and our y axis. So I'm going to start with x. I'm going to open this little doorway, and you'll notice that we are giving an image, or a figure, I should say, not just an ordered pair, not just one point. So the first thing I would like you to do for this first example is, we did this in our last set of notes. Let's start with A, B, and C and just find what are the ordered pairs for those 3 points. Okay, so write the ordered pairs for those 3 points right here. I'm going to pause the video and I will start it up again once I have those ordered pairs written in. You should find those ordered pairs during the pause. Okay, so for A, I had it as -3, +4, B was -3, +1, and C was 0, 1. So we didn't have to move this sideways at all, we just had to go up the 1. So over 0, up 1. Now, since these are being reflected over the x-axis, one strategy would be to look at these and just go, okay, well, how far do I need to move that to get to the x-axis? So remembering that the x-axis is this one right here, it's that horizontal one. So for A, I would think, hey, well, that A is 4 away from the x-axis, so I'm going to put it 1, 2, 3, 4 more away from the x-axis. So without, I don't want to draw arrows here, or else I'm writing over my triangle, but it's 1, 2, 3, 4 from the x, so 1, 2, 3, 4 from the x in the reflection. That is going to be our A prime. B is just 1 away from the x-axis, so B prime is going to end up being 1 away from the x-axis. And then our C is also just 1 away from the x-axis, so C prime is going to end up 1 away from the x-axis. I can connect these, and then why don't you go ahead and fill in what are our new ordered pairs for the image. What is A prime, B prime, and C? So let's check. I got A prime at -3, -4. I have B prime at -3, -1. And I have C prime at 0, -1. Now, on our next problem, we're going to try to find those coordinates first, and then we'll graph it. But let's review what we said about the rule for going over the x-axis. When we go from A to B to reflecting over the x-axis, this is going to become your A, your x-coordinate is going to stay the same, but the y-coordinate, or B in this case, is going to become the opposite. So let's see if that happened. So from A to A prime, we can look at our x-coordinates. They were both -3, stayed the same, but 4 went to -4. So 4 went to the opposite of 4. In B and B prime, they were both -3 in the x-coordinate, but we went from 1 to -1. So went to that y-coordinate, went to the opposite. And in C prime, we had 0 in our x-coordinate, and we had 1 and -1. So we can start to really see how it went to those opposites. So for our next problem, we're going to see, let's find our pre-image coordinates, and then let's go ahead and use the rule to try to find our image coordinates, and then graph it after that. So to start, let's find D, E, and F. What are their ordered? Okay, so let's check how you did. I got -4, 2 for D, 2, 2 for E, and 2, -1 for F. If you got those same things, let's go ahead and apply our rule and find our image coordinates, or our D prime, E prime, and F prime. Remember, for this one, we're going to leave the x-coordinate the same. So I can tell for D prime, my x-coordinate is going to stay -4, because when we're going over the x-axis, we're going to find the opposite coordinate of our y. And then for a y-coordinate of 2 in the pre-image, that means our image should have a y-coordinate of -2, because -2 is the opposite of 2. So let's see, what would be the ordered pair for E and E prime? So we have E, what would be the reflected pair or ordered pair of E prime? Answer that now. The x-coordinate would stay the same, and then the opposite of 2 is -2. So E prime would have an ordered pair of 2, -2. Okay, let's try F next. So in F, our original ordered pair was 2, -1. Using a rule of x-coordinate staying the same, y going to the opposite, what would be F prime? hopefully you said the x stays the same, so those are both going to be 2. And then since in our pre-image the coordinate was -1, the opposite of -1 is just +1. So f prime would be 2, 1. And then let's go ahead and graph this. So starting with d prime, I would go -4, -2. That's d prime. E prime is going to be at 2, -2. So 2, -2. This is E prime. And then f prime is going to be at over 2, up 1, over 2, up 1. This is f prime. And then when I connect these, we start to see the pre-image and the image kind of overlapping, which is totally okay. The original image crossed that x-axis, so the image, the reflected image, will cross that as well. So that's just a good example of how to use that rule with coordinates. I like using that rule when you can remember it, but it's also nice to know how to count on our axes as well. So let's go ahead and let's do our y-axis examples. So our kind of rule or our key idea when flipping or reflecting over the y-axis is that when you have an ordered pair AB, the x-coordinate is going to go to the opposite, but the y-coordinate stays the same. So this time the move was moving horizontally, so that x value goes to the opposite, but the y value stays the same. So let's start off. Let's go ahead and write down what are our pre-image coordinates for A, B, and C. Go ahead and find those coordinates. Now that you have found your coordinates for A, B, and C, I had -3, 4, -3, 1, and 0, 1. Hopefully you notice, hey, those were the same pre-image coordinates we had over here. Yes, it is. It's the same triangle in the same location. Now when it comes to finding our image for A, B, and C, reflecting A, B, and C over the y-axis this time. So over the y-axis, okay? That means this is going to become that horizontal move. We're going to take each point to the y-axis and then take it a little bit further. So starting here with A, that would have to move over 3, so I'm going to move it over another 3. This would be A prime. Same for B. B is 3 away from that y-axis, so it's going to go 1, 2, 3 away over here. And then C is on the y-axis, so we don't even have to move C, which means C prime is actually going to end up in that same spot. It's kind of like when you touch your finger to the mirror, it almost looks like your finger is touching your reflection's finger, and that would be the same case here. Since C is already touching that line of reflection, C prime is going to be touching it as well. That means we can connect these dots like this, and then let's go ahead and find what are our new reflected coordinates. Go ahead and do that now. Alright, so for my reflected ordered pairs, I have 3, 4, 3, 1, and 0, 1 for A prime, B prime, and C prime respectively. Alright, next is going to be our triangle DEF. Let's go ahead and start by finding the ordered pairs for D, E, and F, and then we will apply our rule this time first and graph second. So go ahead, find the ordered pairs for D. Alright, I have -4, 2 for D, 2, 2 for E, and 2, -1 for F. So when it comes to finding our image coordinates, or D prime, E prime, and F prime, we are going to apply the rule that we need to find the opposite of our x coordinate, and we're going to leave our y coordinate the same. So coming over this way, so for D to D prime, the opposite of -4 would be 4, and then we're going to keep 2 the same. So I would like you to apply that rule for E prime and F prime. We'll do one at a time, but go ahead, find E prime now. Okay, I have E prime as -2, 2, because our x coordinate 2 went to the opposite of -2, and our y coordinate 2 stayed the same. Let's find F prime now. Okay, F prime prime would be at -2, -1, because we took 2 to the opposite, so 2 to -2, and then our -1 stayed the same. So let's graph this. Last step here, d prime, e prime, f prime. D prime would be at over 4 up to d prime. E prime would be at -2 to e prime. And f prime is going to be at -2, 1, -1. That's f prime. And then we can connect, and we can see how these are reflections to each other. Remember, it's okay that they're crisscrossing. That's because the original was crossing the axes, so the reflection will as well. Okay, now we're going to go talk about the origin. Okay, and our origin and reflection over x = y are a little bit different because there's not a set line just right on the graph. You know, for these first examples, we knew we were reflecting over this line or we were reflecting over this line. For this next one, it's more about our reference point. So what I like to say for when reflecting over the origin, instead of thinking of it, okay, let's go to the x-axis or let's go to the y-axis, and then you go that more, you're going to do both. You're going to take it to the x-axis, you're going to take it to the y-axis, and then you're going to repeat that on the other side, or you're going to repeat it a second time. So what this would look like. So I would start here at our original point, which is at 4, 3, and I'm always going to go down. That's just kind of my preference here. I'm going to go to the x-axis first. So I know that I need to go down 3 from our original to get to the x-axis. And then I would follow this x-axis to get to the origin, because remember that origin's that point right there in the middle. That means I need to move over 4 to the origin, and now I'm just going to repeat that for this next step. So you can do it in either, like you could have gone over and then down first to begin. It doesn't necessarily matter. So you show it how you'd like to. What I typically do here is I would repeat that 4 again, and then take it down the 3 again. So see how you kind of get that zigzag going? That tells me that my new ordered pair would be right here, which is at, since it's 4 to the left and 3 down, that would be at -4, -3. So again, similar to how we graphed the other ones, you have to get to the origin, and then you make those same movements on the other side of that origin. It was down 3 over 4, so over 4 down 3, or I could have gone down 3 over 4 as well. As long as you're repeating those changes both ways. What we'll notice, our original point, both numbers were positive. It was 4, 3. And then in our reflected point, it was -4, -3. So what we say for reflecting over the origin is that both the x-coordinate and the y-coordinate need to go to the opposite. 4 went to -4 and 3 went to -3. So both of those go to the opposite. So let's open this one up and try these here. I would like you to use our key idea or rule of the x and the y coordinates going to their opposites. So let's copy down what are our ordered pairs for A, B, and C. Here's a hint. They have been the same all throughout these notes. So these A, B, C's here are going to be the same. Don't be fooled, though, the image is going to be different. So go ahead, write in what are the ordered pairs for A, B, and Okay, so I have my A, B, and C, and now I'm going to show you on this one how to use our rule to get our image coordinates, and then we'll graph it, and then I'm going to have you do D, E, and F. So starting here, if I know, since we're going to the origin or going over the origin, that both x and y are going to the opposites. So if this is -3, 4, for A prime, the opposite of -3 is 3. And the opposite of 4 is -4. That's that reflected point. And then for B, B prime, the opposite of -3 is 3. And then the opposite of 1 is -1. Okay, so see, I'm just doing those opposites. For C prime, the opposite of 0 is still 0. 0 doesn't have an opposite. Okay, and then the opposite of 1 is -1. So when we go to graph these, we're going to graph these 3 new ordered pairs. So I'm going to go to 3, -4, be right here. That is A prime. B prime is going to be at 3, -1. and C prime is going to be at 0, negative 1. And once we connect these, you start to see how that reflection has flipped it and flipped it a second time, which is what we get when we're going kind of over and over this way. So using our rule, we were able to make that reflection over the origin. So I would like you to do D, E, and F in entirety. Okay, start by finding your pre-image coordinates, and then apply the opposite to both the x and the y for your image coordinates. Go ahead and do that now. Okay, I made a little bit of an oopsie. I was writing those ABCs and it should have been D, E, F, but compare yours to mine. How did you do? I'm going to go ahead and graph our new ordered pairs, our prime ordered pairs. So D prime would be at 4, negative 2. That would be my D prime. And then E prime is at negative 2, negative 2. And F prime is at negative 2, positive 1. And I would go ahead and connect those. And again, we have some overlap in our shapes, and that's totally okay. So that is reflecting over the origin, remembering that it's that sense of we're getting to the origin and then reflecting that, doing that a second time. You can use our rule of the x coordinate and the y coordinates go to their opposite. The opposite of 2 is negative 2, and the opposite of negative 1 is positive 1. All right, and last but not least, let's talk about reflecting over x equals y. So I said earlier that the reason some of these are tricky is that we don't have a line kind of there to compare it to. So one thing I always like to visualize, and I will often draw this in, not that you have to, is I'm going to add in what does the line y equals x look like? Well, essentially what they're saying is when x equals 1, y equals 1. When x equals 2, y equals 2. And they're always going to be equal to each other. So we kind of create this line that goes this way. So just putting really small dots. And again, it's not something you have to do, but for our notes here, it's a good visual so that you know where is that line. Like what are we reflecting over or to? So when y equals x, you're going to get that vertical line from left to right, making sure that when x equals 1, y equals 1. When x equals 5, y equals 5. So that's our line of reflection. That's what we're reflecting over. And we are going to solve this similarly to how we did. Now, in this particular example, our ordered point, or ordered pair, is really close to that line of reflection. So when I say, hey, you're going to count, how far over do you have to go? Again, I usually go over first. You could go up. It's not wrong. I would notice, hey, this ordered pair is only 1 away from the line of reflection. Over 1 away from our y equals x. So you're then going to go up 1. So this one is a little different from the others because it's not going the same direction. When we did our y, we went over 4, so we went over 4 more. Even in our origin, we went down 3 over 3, or over 4, so we went over 4 down 3, or down 3 over 4. It was that same movement repeated. For our y equals x, or reflecting over y equals x, how far it is from the line of reflection in the x is how far it's going to then turn and go in the y. So we just had to move over 1 to get to line of reflection, so we're going to go up 1 to get to line of reflection. And essentially what this is doing, if our original pair was over 4 up 3, that's the original point was at 4, 3. Our reflected point is now over 3 up 4. And we start to notice, hey, those are the same numbers, we just flip them around. So our key idea, or our rule for reflecting y equals over y equals x, is that the ordered pair A, comma B is actually going to reflect to the ordered pair B, comma A. So those numbers just switch spots. So let's go give that a try. Okay, first things first, let's start with those pre-image coordinates, A, B, and C. Go ahead and find them now. Okay, I have -3, 4, -3, 1, and 0, 1. I'm going to demonstrate this first one for you, and then I will have you solve it on our DEF triangle. So we have A prime, B prime, C prime, and I'm just going to use our key idea that these two numbers switch. So if we're reflecting over that y equals x, and again, if you like having that little visual of a line there, gently, if you're with a pencil, you could just very faintly do it. I'm just kind of dotting to represent that set line. Okay, these points are simply going to make those changes. So again, if you want that visual, I'll show that here. Okay, A is 7 away from that line of reflection. 1, 2, 3, 4, 5, 6, 7, which means I'm then going to turn and go down 1, 2, 3, 4, 5, 6, 7 here as well. Okay, and that's what the reflection looks like. Okay, but that point's going to end up right here, which is now at over 4 down 3, which would be positive 4, negative 3, noticing that it is just those two numbers flipped around. Okay, so we don't like to draw those arrows every time when we have our rule. If I'm going to be reflecting B prime, I'm just going to switch to negative 3 and 1. So my new ordered pair would be at 1, negative 3. And I'd be over 1 down 3. Okay, this was A prime, this is B prime, and then C prime, 0 and 1 becomes 1, 0. And C prime would be over 1, and then it wouldn't go down at all. So this would be our C prime, and I can connect them just like this. All right. So let's go ahead and have you try that on triangle DEF. Go ahead and find the pre-image and the image coordinates now using a rule that the x and the y coordinates switch. Okay, this is what I got for DEF. So I have my D prime is 2, negative 4, E prime is 2, 2, and F prime is negative 1, 2. Now, what I'm hoping some of you notice is, well, wait a minute, E and E prime are at the same spot. And when we look at that on our triangles, it did end up there. The reason for that is that E is actually on our line of reflection. E is an example of when y equals x, which was our line of reflection here. So the point doesn't move because it's already on that line of reflection. It's like when your finger's touching the mirror, it looks like your reflection's touching the mirror as well. So hopefully this helped clear up some of what we are learning in this section for reflections. We're going to go ahead and take this to our notebook now, and we are going to glue it in, and then we are going to write one more thing at the top. So let's have you grab a glue stick. Okay, our last set of notes were our ones on translations. Let's go ahead and turn to our very next page. And then, like we did last time, I do want you to try to glue this kind of farther down at your notebook so you have a little bit of space up here at the top so we can write in some important ideas and things that we need to remember. So go ahead and glue yours in now. Okay, once those notes are nice and glued in, you can go ahead and kind of write our title and our definition of a reflection. So reflections are a transformation in which a figure is reflected or flipped over a line of reflection. So go ahead, finish writing that into your notes, and then that is all for today's note.